Cool. I think we're live. Fantastic. All right. Well, good morning, everyone, or good evening from New Zealand, where I'm at the moment. Welcome to DDD 2020. My name is Will Velida. I'm a software engineer and Microsoft Data Platform MVP, and welcome to this session on building machine learning pipelines and models using ML.NET. Now, if you don't know who I am, my name is Will Velida. I'm a software engineer in Microsoft Data Platform MVP, living and working in Auckland, New Zealand. But if you've detected the accent, I am originally from the UK. I'm a C# developer in my day-to-day work, but I also get to work with a variety of different technologies such as Azure Cosmos DB, Azure Functions, Event Hub, Service Bus, etc. But I also like to play around with ML.NET when I can, hence the talk today. And before we kick off, just want to give a big shout out to all the sponsors of DDD 2020 today. Make sure you thank them too. And just because it's a virtual conference doesn't mean we can't be social. Make sure you tweet about the event, what you enjoy about the event, connect with other attendees using the hashtag following Developer Day, and just enjoy the day. And also, there's a bit of a fundraising drive for the National Museum of Computing. So if you want to help out a really good cause, just check out that link and let's raise some money for those guys. Cool, so what are we going to talk about today? So in today's session, I'll go over what ML.NET is and what kind of predictions we can perform using ML.NET. Then I'll talk about the different ways we can actually use ML.NET and build models using ML.NET. So that's using the model builder tool, the command line interface tool, and the API for more custom solutions. Throughout, I'll explain what the tool is, and then we'll dive into, we'll go through a bit of a demo to actually demonstrate each tool. And at the end, we'll have a Q&A session. So if you have any questions, wait to the end, pop them in the chat, and I'll be happy to answer them at the end. So let's start with what ML.NET is. So ML.NET gives us the ability to add machine learning capability to both our online and offline .NET applications. And essentially, we can make predictions with using the data available within our applications using ML.NET. Now, central to ML.NET is the idea of a machine learning model. And this model specifies the steps needed to transform our input data into predictions. Using ML.NET, we can train a custom model by specifying the algorithm that we need, or we can even leverage other libraries and import pre-trained models, such as, for example, models that are trained using TensorFlow or Onyx. And then once we've trained our model, we can actually add the model that we've trained to our application in order to make predictions. Now, in ML.NET, we can perform a variety of different predictions due to different tasks that we can perform using ML.NET. Now, a machine learning task is essentially just a type of prediction that's being made based on the problem that we're trying to solve with the data that we have. In ML.NET, we have a variety of different algorithms available to us based on the type of task that we need to perform for our scenario. So, for example, we could be working with customer feedback, and we want to detect whether that feedback is negative or positive, so we can use classification for that. We might want to predict the price of a product based on some input parameters, and for that we can use regression. We might be building applications to detect fraudulent transactions, so we can use anomaly detection to, machine learning tasks for that. We might want to build product recommenders based on what our customers have previously purchased. We might want to recommend new products, and for that we can build recommendation applications. We can do some forecasting using some time series and sequential data machine learning tasks. And then we can do some classical, is this picture a cat, is this a dog, using image classification. So how can we build machine learning models in ML.NET? We have a variety of different options available to us. So we have two low-code options, and these are both the model builder tool and the command line interface tool. Or we can use the code first option to build more customized models using the ML.NET API. And throughout this talk, I'll actually go through each tool and how we can actually build models with it, and then show you guys how you can do it. So let's start with the model builder tool. So essentially, the Model Builder tool is a graphical tool that we can use to build, train, and deploy custom machine learning models. It uses AutoML, which is just the process for automating the process of applying machine learning to real problems, to explore different algorithms that we can apply to our data, and then it finds the best one suited to the problem that we're trying to solve and recommends it. The great thing about the Model Builder tool is that we don't have to be experts in machine learning to use it. All we need is our data and the problem that we're trying to solve with that data. The Model Builder tool will actually just generate the code that we need to add our model to our .NET application. So let's have a look at this in action. Now, I'm going to jump into our first demo. So just what I've got is just a simple Visual Studio Console application. Before I actually show you this, you can get the ML.NET Model Builder tool from the Visual Studio Marketplace, just as long as you've got Visual Studio 2017 or 2019. You just download it and just apply it to your Visual Studio instance. But I've already done that for you, so we'll just go back into this console application. Now what I've got here is I've got a simple CSV file containing some data related to taxi trips. And I'm actually just going to open this so we can have a look at it. And essentially what it is, it's just we've got some basic data on some taxi trips. So how much the taxi trip cost, that's okay. Who was the vendor? If there was a specific rate code applied to it? How many passengers were on that trip? How long the trip took in terms of time? How long the trip was in distance? How the customer paid for it, and how much it cost. So very simple, very basic data set that we're working with, and nice and clean as it would be in real life situations. Anyway, all right, so let's go back into Visual Studio. And when we install the Model Builder tool extension, what I've done is I've right-clicked my solution, and we can add this machine learning capability to it. Really simple and straightforward. But what that will do is I'll actually start the graphical process of applying a machine learning model to our application. So first off, when we use the Model Builder tool, we need to select a scenario. Now we can select a few scenarios. So we could do some text classification, we could do image classification. The nice thing about image classification and object detection is if we have an Azure Machine Learning workspace, we can actually use that as our training environment rather than our local machine. We've also got some limited examples here. So anomaly detection, forecasting, and clustering. But for this demo, we want to predict the price of, we want to build a model that predicts the price of a taxi trip. So essentially this is a regression problem, so I'm going to use value prediction. Now with the Model Builder tool for regression tasks, we can only use our local training environment. So I'm just going to pick that as my training environment. And then we're going to need to supply the Model Builder tool some data. So for this, we can use a file, so a CSV file, tab, a TSV file or a text file, or we can provide it SQL Server or data from SQL Server. But I've got my file here, so what I'm going to do is just going to add that as my data source. And then we see a little data preview table shown underneath. But what we need to do is we need to pick the column to predict. So we need to choose our label. And since we're choosing how much a taxi trip will cost, just click fair amount. And then here we can actually choose which columns we want to include in our training data set or which columns to exclude. So here we can just go into advanced data options. And for this demo, I'm just going to ignore the time taken in seconds. I'm just going to focus on trip distance, passenger count, rate code, who the vendor was, and payment type. So click save, and we go next step. And then we need to specify how long we want to train, how long we want to train over our data. And essentially what happens during this time is we'll specify a time. So here I'm training it for 10 minutes, and the model builder tool will iterate over our data and assess the performance of different regression algorithms over our data set to recommend the best one. So if I click start training, I'm not going to make you guys watch this for 10 minutes. So here's one I made earlier. And what we can see here is the graphical tool has suggested the best model for our data. It's given us an R-squared value, so essentially saying that this model has a 91% fit over our data, so it's a very good fit. How long the training time actually took, and how many models it explored. And if you have a look at the output here, we can actually see all the different algorithms that would were evaluated during the training time. And then we get a nice little summary saying what the ML task was, what the data set was used, what our label was, how many models it explored, and then it shows us the top 5 performing models. So once we've done that, we can click next step, and then we can actually evaluate it. So here we've got some sample data, and we can actually play around with this a little bit, and just click the predict button and just do some prediction testing, just to test it. I'll test the generated model or suggested model. And this is good that if you have a data scientist in the room, you can actually say, okay, this is the kind of data we expect. Does this result make sense, before we actually generate the code that will have this model included. So if we're happy with that, we just click next step. And then we can generate some code that can actually consume the model, and we can use to make predictions in the future. So just add to solution. And what we can see here on the side, oh, Visual Studio not responding. Oh, there we go, that's okay. So we've got this project for our model. So thank you. So we've got our serialized model here. We've also got some code that actually consumes the model, actually loads and creates the prediction engine needed for the model. We've also got an input class, so this will be the data that goes into the model to retrain it, and then an output class, so that'll be an output result of it. And then we've got this console application that actually shows you, generates some sample code on how you can actually consume your model within your application, and you can tailor this depending on what application you're going to be using it for. All right, so I'm just going to step back into presentation. Cool, so before we move on, there are some current limitations that we need to keep in mind when using the model builder. Now, the model builder extension currently only works on Visual Studio for Windows. So if you're a Mac user, you won't be able to use this. There's also a limit for training data set of 1 GB. And if you're using training data from SQL Server, that has a limit of 100,000 rows for training. So let's move on to the command line interface tool. So essentially, the command line interface tool is a .NET Core tool, and you just provide it with a machine learning task and a training data set. And what it will do, it will generate an ML.NET model, as well as some C# code that we can use to run our model within our applications. Now, with the command line interface tool, there are some advantages and disadvantages, and one of the disadvantages is that we are limited in the types of machine learning tasks that we can currently use. These are limited to classification, regression, recommendation classes, tasks, and image classification tasks. But it's an evolving tool, so more are being added. However, the plus side is, unlike the model builder tool, the command line interface tool is cross-platform, so it can work on Windows, Linux, and Mac OS. Now, when we use the command line tool, it will generate a serialized zip file containing our model, along with a C# solution that we can use to both train the model again for future use and to run the model so we can make predictions. We'll also get a log file that shows all the information of all the multiple algorithms that were assessed and evaluated. And this is really great because we can use this as an investigation point to see other algorithms that were assessed. So if our solution or scenario changes in the future, we can actually use this as a source of investigation. All right, let's jump back into another demo and go over the command line interface tool. So just go into, all right, so I've got my command line interface tool here. Let me just set up my demo. Okay, so it's like I said, it's a .NET core tool. So what we can do, if we wanted to install it, let me just. So if I just type ml.net, we can see that we have a variety of different commands that we can actually provide it. So like I said, we are limited in the type of machine learning tasks that we can actually use. So these are classification, regression, recommendation, and image classification. So in this, I've got a folder here for my command line interface tool demo, and I've still got that taxi to fair data. So what we're going to do, we're just going to type ml.net. Then we need to specify the task that we want to run. And in our case, that is a regression task. Now, first up, we need to provide it some data. So that's going to be our CSV file. So all we need to do is just type dataset. And just make sure I get the name right on this. Taxi CSV. Cool. Then we need to pick our column for our label that we want to make predictions on. Now with ml.net, if we have using our CSV file, this will work on a zero indexing basis. So your first column will be 0, and then your second column 1, etc., etc., etc. Now, since we want to predict our fair amount, this was the last one, so we have 7 columns in our data set, so we'll pick 6 as our column. Then we just specify whether the file has a header or not, and it does, so that we set to true. We want to give it a training time, and this time is in seconds, so I'm just going to put 600. Now, again, I'm not going to make you guys watch this, so here's one I've made earlier. And it's very similar to the output that gets generated during the model builder tool within the output window in Visual Studio. So as you can see, here are all the different algorithms that were assessed during our training time. And then we get a nice little summary. So I've got the type of machine learning task that we wanted to assess, what the data set was. We've got this fair amount as our label, how long the experiment took in seconds, and how many numbers were explored. And here we can see that these were the top 5 models performed. So we've got a nice R-squared value for our light GBM regression. And we can see all that fast tree regression was also assessed as well. And as we can see down at the bottom here, it's generated some C# code for our model consumption. So we've got this sample regression console app. And we've also generated a log file as well. So what I'm going to do, here is our generated code for that, generated code from the command line interface tool. Let's see if I can show you guys that log file as well. I'm running all the things on my computer. So this is some good fun. Let's see if I can find that app data. File for you. It's in a temp drive. ml.net. Cool. So yeah. So it's essentially just produced a log version of what the output, just a log file of what this output is, what the output has been generated from the command line interface tool. But then you've got an actual file that you can work with and use as investigation. And then if I open up this sample regression Visual Studio sample regression solution. We can see our serialized model has been generated here. We've got our input schema, our output schema. Got our program where we can actually create an instance of example inputs, and then we've got this consume model. We've got code that's generated that allows us to actually consume our model and make predictions on, and which we can add to our applications, which is pretty cool. So that was a real, those are two very basic ways, or low-code ways, where we can actually use the data set, provide a scenario, and just generate some code that generates a machine learning model built using ML.NET for use in our .NET applications. All right, let's now start to look at the ML.NET API, which is a code-first option for generating and building custom machine learning pipelines and models. So it all starts, each ML.NET application will start with an ML context object. And this is a singleton object that contains something called catalogs. And essentially these catalogs provide methods for a variety of different operations that we need to perform when building machine learning pipelines. So for example, we have catalogs to load our data, to prepare our data for our pipelines, training the algorithms that we want to use to solve our problems. And then once we've trained our model, we have catalogs that we can use to use the model once we've trained it. So using the API, we can load our data from files or any other external sources. So if we're loading our data from files, we can actually load data from a single file. We can load data from multiple files in a single directory, or if we have multiple files written in multiple directories, we can use the API to load all those files into our ML.NET applications. We can also load data from a variety of different relational stores that are supported by the system.data namespace. So this will include stores like SQL Server, Azure SQL Database, Oracle, SQLite, Postgres, and many more. Or perhaps we need to load our data from in-memory collections or JSON and XML sources. And we can do this using the load from enumerable method. Now, this method does assume that the IEnumerable object from which you're loading your data is thread safe, but if you have JSON data and you want to train machine learning models using that JSON data, you can use that method to do that. So when we load our data, we'll load them into something called a data view object for transformation. And data view objects are core to pipelines in ML.NET. Each transformation will have an input schema. So remember that input class that the model builder tool in the CLI generated before. This essentially is an input schema which will include the data names, the types, the sizes that the transform will expect to see as an input. And each transformation will also have an output schema. So we have our output class that was generated before, and this just includes the data names, the types, and the sizes that the transform produces after the transformation has taken place. And if these don't match, ML.NET will actually throw exceptions for that. Now, when we have our data, we need to prepare it in the format that's expected by the algorithms that ML.NET provides. And this may involve cleaning our data, working with different types of data, replacing missing data, etc., or to make our data, for the purposes of making our data acceptable for use in ML.NET applications. The data operations catalog has a variety of different operations that we can use to take our incoming data and then produce an iDataView object containing the data ready for use in our applications. Now, depending on the nature of our data and the problem that we might want to solve, our approach to data preparation will change. The thing to note here is that all algorithms in ML.NET expect a float vector of a known size as an input. So essentially what we need to do is we need to convert our data into numerical format and then process it into a features column in order to predict our label. So taking this code snippet, for example, what I've got here is we're creating an output column for a label. that we're trying to predict. So I've got my fair amount column, and I want to produce an output column name of label, because that's what we want to predict. We're then transforming our categorical data by applying one hot encoding on 3 input columns and then producing 3 output columns. Now, one hot encoding essentially takes a finite set of values, then removes implicit ordering of our data. So these are 3 categorical columns that I'm applying this to. So I'm just saying for each category, give them a binary value. And then once you've given them that binary value, remove any ordering from that. So it doesn't. So our algorithm doesn't think, okay, 1 is more important than 4, or 4 is a stronger weight than 1. So it just removes any ordering from our binary values. Now, once we've transformed our columns, we then concatenate them into a vector column called features. And then after this is done, we append the algorithm that we want to use in order to solve our problem. Once the data is processed, we can then use the fit method to train the machine learning model with our regression algorithm. Now, in order to make a decision on how well our model will perform, we need to evaluate its performance on test data, and we can do this using the evaluate method. Depending on the type of machine learning task that we're performing, different types of metrics will be generated. But just taking this example, what I'm doing is I'm loading our test data into a data view object, and then using our defined model in order to make predictions on our test data. The evaluate method here applies to a regression model. So we evaluate our predictions to the label that we're trying to predict, and this will generate different types of metrics. So here I'm just getting the R-squared value to see how well this model, how well our algorithm fits over our data. And that, depending on the type of machine learning task that we want to perform, this will generate different types of metrics. Now, once we're happy with our model, we're satisfied that it performs well, we can actually save our model. Now, in ML.NET applications, once we've built our model, they're only available in memory. So once we stop the application, we'll lose it. So in order to keep our model, we'll need to save it. In ML.NET, the process of saving and using models are universal to all different types of algorithms that we can use in ML.NET. And when we save a model, we'll need 2 things. We'll need the model itself, and then the data view schema of the model's expected input. When we load our data, we simply call the load method if loading a model that's stored locally, or we can use a stream to load a model that's stored remotely. And then once we have our model, we can actually start to make predictions. So we can input data to make bulk predictions or a single prediction at a time. And for this purpose, we create something called a prediction engine, which is just essentially a class that helps us make predictions. So in this example, I'm calling the predict method here and passing both the model I want to use and some input in order to make the prediction. Now, with prediction engine, bear in mind that this isn't thread safe. So if you're making a single prediction, that's okay. But if you make multiple predictions within your application, you'd have to create instances of this prediction engine class everywhere. And as your app grows, this becomes more and more unmanageable. So the answer to this is a prediction engine pool, as we'll see in the demo that I've cooked up. So with this, you can use it with dependency injection, and what it will do is it will create an object pool of prediction engine objects that we can use throughout our application. So just taking a look at the high-level workflow of the ML.NET API. So here you would start by collecting and loading your training data into your iDataView object. We'll then specify a pipeline of operations to extract features and apply a machine learning algorithm when we create our pipeline. We can then train our model by calling the fit method onto the pipeline, and then we can evaluate the model. We can evaluate the model, assess its performance, and then iterate it if we need to improve it. But if we're happy with it, we can save the model into a binary format so we can use it within our applications, and then load the model back into an iTransformer object within that application and start to make predictions using that model by calling the create prediction engine predict method, or having that prediction engine pool if you need to make multiple predictions within your applications. All right, let's kick off our ML.NET API demo. So what I've got here, just come into the serverless price predictor. Essentially what I've got here is I've got two Azure functions. So I've got a timer trigger function that's going to call, actually going to train the model, and then we're going to consume that into an API. So if we go into our model trainer first, now as you can see, this is one I've made earlier, so I've installed all the dependencies. But if I just go into manage NuGet packages, I'm just going to type in Microsoft.ml. Oh, should I spell that right? And as you can see, we've got all these packages available to us that we can import into our .NET applications and use them for the purposes of building machine learning models. So here I've got the packages so I've got the base package here, Microsoft.ml. I could update it if I wanted to, but I won't do that for this demo. And then if we wanted to use the fast tree algorithm, we can just install that package. We want to do some image analytics. We've got that light GBM regression model that fitted so well earlier. If we want to do some vision stuff, we can use the Microsoft.ml.vision package, NuGet to work with image classification. We've got some for time series, TensorFlow, etc., etc. So there's a variety of different packages that we can use depending on the task and the problem that we want to use to solve our problem. But let me just go into the startup class, and I'll actually just increase the real estate. That's going to be too small as well. I'll always miss out. I'll just keep it all on 50. Actually dive straight into these models. So here I've got my input class. So again, I'm working with some local data, and I'm loading in loading that data into my application, again using that zero-based indexing. So for vendor ID, rate code, and these will all match their particular columns within that file. And then I've got this model trainer timer function. So essentially what I'm going to be doing is I'm going to be training my model based on some local data and then uploading that model to Azure Storage. So let me just kick this off, make sure that's started. We'll step through this function as it runs. Cool, so we'll start off by actually connecting to our storage account. Then I'm just reading my local data. So I've got one for my training data and also my testing data. And I've defined a model path, which is just going to be a zip file that I'll upload to Azure Storage. So now I've got this train and save model method, and I'm passing through my ML context, my training data, testing data, the model path that I want to save it to, and the actual container in Azure Storage that I want to train my data, save my model to. So I'll step into this method here. And essentially, with this training data, I'm loading that from our text file, and then just saving it to this iDataView object. And with this, we can actually define, pretty similar to the CLI tool and the model builder tool, defining whether this file has a header and also defining the separated character for our data set. So just go through into the next. And then we just create our pipeline. So again, I've got this output column of label, which is essentially I'm just telling my pipeline saying, hey, I want to predict the fare amount for each taxi trip, applying that one hot encoding on my categorical data, and then concatenating these features So the vendor ID, the rate code, passenger count, trip distance, the payment type into this features column, and then I'm applying a fast tree regression algorithm onto my data. Once we've got our pipeline, we can then fit it onto our testing data set. Hopefully this won't take too long. But essentially what I've done is I've created my pipeline here, applied some simple data transformation, and then just fit it onto our data view. Okay, so now we can actually test the model and evaluate its fit. So I've got this evaluate method, which I'm just going to step into. I'm passing in my ML context and my testing file, or testing data file. Again, I'm loading my testing data into a data view object, and then I'm just transforming that data set, and then I'm generating some metrics based off this testing data view that I have. Now, since this is a regression task, we'll see here we've got a type of data.regression metrics. So this will produce different metrics. What ML.NET does, it produces different metrics depending on the type of machine learning task that you want to perform. So here, since we're using regression, I've got loss function, mean absolute error, mean squared error, R squared, and then root mean squared metrics generated to assess the fit of this regression model over my data set. But for the purposes of this demo, all I'm going to be doing is extracting this R squared value based off our metrics, and then just returning that. And what this is actually demonstrating, we can now assess, by using these metrics, we can actually assess whether we want to use this model within our applications. So if you imagine a more sophisticated example where we've got streaming data coming in, and we need to, as new data comes in, our models are going to get old, they're going to get stale. So we need to be able to evaluate the or assess their fit to see if they're still fit for purpose as we get more and more data, and make sure they're actually doing what the models are designed to do. Then using this information, we can actually save our model now. So we say, okay, this model's a good fit. We can save our model here. And then once we've saved our model, we can actually upload it to Azure Storage. All right, so that should be our model trained. So if I go into my storage account now, so here's the storage account that I've saved my model to. So I'll just go into my containers. I've got a container called ML models where I've saved a zip file, and there it is. So here's our model saved from our model trainer function, and we can now use this model to inject it into our applications. So let's have a look at that. I'm just going to stop you, and then I'm going to just create some more real estate for myself here and set up the API project as my starter project. Okay. So if I look into the startup here, essentially this is just going to act as like an API where we've actually consumed our model, and we can make predictions based on the input that we pass through to our API. So what I've got here is I'm adding this prediction engine pool service. So essentially here I've got my input class of taxi trip, and then I've got an output class of taxi fare prediction. So very much similar classes as we use in our model trainer. So here's our input data, and then we've got a class for our fare amount, which we want to predict. And essentially with this add prediction engine pool service, what we can do is we have two options. We can import a model from a remote URI, which was what we're doing here. So we just give our model a name, we define the URI where the model is actually living, and then we can specify a period. And what this does is this will actually poll this URI for any changes to the model, depending on the time span that we can give it. And we also can do this from a local file as well if we're working with on-prem applications. But essentially that will just poll a directory for any changes to our model. So if you've this API is hosted somewhere, say in Azure, you don't have to bring this application down, retrain your model, and then bring your application back up as well. What this method allows us to do, what this allows us to do is just poll that remote location for any changes to our model, and it just injects it, the changes that when they occur. Cool, so if I go into predict taxi fare, this is just an HTTP trigger. So essentially what we're going to do is make a post request, and we're going to read this body, deserialize it into our taxi trip object, and then use this input in order to make predictions. So here I've got our taxi trip model. Now we can give our models any names that we like once we've injected it, but once we've defined it here, we have to use we have to keep those names consistent throughout our application. So say if I had another function, I'd need to call this need to keep this model name the same. But essentially I'm just using this model in order to make predictions. And then I've just got this insert DTO object, which I'm going to try and insert into an Azure Cosmos DB container if successful, and then just return the object back to us. So let me kick that off, and I'm going to test this using Postman. So once that function starts up, we should get a URI which we can use to test with. So there it is. So it's just a local URI, and then we can use that to send a post request. So what I'm going to do is I'm just going to extend our trip time by 10 minutes, sorry. Yeah, we'll decrease the passenger count, maybe use a different rate code, not 21, 2. And then we'll say it's a longer trip, say 4.5 miles. Say give it a fare amount of 15. So I click send, and then hopefully, go back into Visual Studio. So we're going to be reading the request body, deserializing that into a taxi trip object, and then make a prediction. And then once we've made our prediction, we're going to actually insert it into Azure Cosmos DB. So if I look at the predicted fare amount, it's quite a bit off. That's okay. It's just an example. Just click continue. Cool. And then we should get our return value back to us. Sweet. So there's the body returned to us. So we've got our original post request that we sent along with a predicted fare amount. If we go back into Azure, what I've done is I've got a simple container where I'm going to be storing all my predictions. Go into Data Explorer, open up my taxi database. Should have 3 items. What I'm going to do is just order it by time descending so I can get the latest one. And there you can see our taxi fare prediction has been successfully added to Cosmos DB. So just a basic example or just a basic application, but it shows how powerful it is. We can actually inject machine learning models that we've trained into our .NET applications. So say if we had an actual web API that rather than just a function, we can inject our models into that to build some really powerful, give our .NET applications some powerful machine learning capabilities. Cool. So thanks for joining. So what we've covered today is we've gone through what ML.NET is. We've discussed what kind of predictions that we can do and perform using ML.NET. We also discussed what the model builder tool, the CLI tool, and how we can, and also the API. So show you how we can actually build machine learning models using ML.NET, the different options available to us, ranging from low code right to more deep dive solutions for more customized machine learning models. Went through some demos. Now, if you want to learn more, I'll I'll stick the links to these either in the chat or just on my Twitter account. But the ML.NET team have produced a variety of samples that they've hosted on GitHub. So if you want to explore different types of machine learning tasks, I definitely recommend checking that out. If you're brand new to ML.NET and you just want to take it a little bit slowly and you want to take your time on to find out how you can install the model builder tool, the command line interface tool, and you want to go through some step-by-step tutorials, I definitely recommend checking out the documentation. I've got the code for the API demo that I've just shown you now on my GitHub. If you want to have a play with that and just see how that all works in your own time, please check it out. And then I've also got links there for installing the model builder tool and installing the command line interface tool. So thanks for coming. I hope you enjoyed it. I hope you learned something as well. If you do have any questions, I'll be checking the chat in a bit. Or if you want to reach out to me via Twitter, my Twitter handle is Will Velida, nice and straightforward. Or if you want to reach out to me on LinkedIn, I'm happy to answer any questions. Cool, so thanks for joining. Let me have a look at the Q&A chat now. Okay. Oh. All right, so are these sessions available after conference? Yes, they are. Is the model builder tool available outside of Visual Studio, e.g. Rider or VS Code? It won't be available for Rider, I don't think. VS Code, I'm not too sure about. I want to say no, but I'm sure VS Code has lots and lots of extensions, and I'm sure someone is either working on an extension for the model builder tool, or there is one already. I'm not too sure. I'll have to check that one out. Anyone else lost sound? I hope you found sound again. I think that's all the sessions. So all the questions, sorry. So Adam, what are next steps? We're just hanging out?
I think we're done. So yeah, thank you very much. Awesome presentation.
Cool.
Well, yeah, we can't really give a polite round of applause here, can we? So maybe I can do it, and then
I should have a machine.
Thank you very much.
Awesome. I was going to say I should have a machine where I have all the sounds, so sympathetic audience, booing.
Maybe I should look up some Foley recordings for the next talk.
Definitely recommend.
You got 20 people here, so you slightly more than you started with. So you must have made somebody happy. So awesome. Anyway, have a good sleep. Cheers for the great talk.